In this video, we're going to focus on algebra, one of the most important topics in high school mathematics. Now, although algebra wasn't tested in term 1, it will be examined from term 2 onwards. And here's the important part. There's no new algebra content added on in grade 12. What this means is that the algebra you'll be tested on is mainly based on concepts from grade 10 and grade 11. So in this video, as well as the next few, we're going to revise those core concepts. But we'll be using questions from grade 12 past papers so that you're exam ready for term 2. So in this question 1.1 starts off with solving for x. We're given 3x squared plus 5x is equal to 0. So for this type of question, we've got a binomial, and we notice that both terms have x in common. Let's pull out x as a common factor. In the first term, you are left with 3x. In the second term, plus 5. That is equal to 0. So you guys should remember from the previous 2 years that when we are solving for x, once we factorize, we take each factor and we equate it to 0 separately. So we have x is equal to 0 or 3x plus 5 is equal to 0. And bear in mind that they are quite particular about you having the word or in between your two solutions and not the word and. So in the first equation, we've got x is equal to 0. We cannot do anything further. But in the second equation, let's take the positive 5 over to the right. It becomes negative 5. Let's divide throughout by 3. So we have x is equal to negative 5 over 3. So those are our two solutions for x. Now 1.1.2, we've got 4x squared plus 3x minus 5 is equal to 0. And in brackets, it says answers correct to 2 decimal places. You had this type of question in your grade 11 papers last year. And you know that whenever you have brackets and it tells you how many decimal places they want, that is a clear indication that you need to use the quadratic formula. So we know that the minute we see this bracket, it means use a quadratic formula. And we always pay careful attention to how many decimal places they're asking for. Here, they want 2 decimal places, which is fine. That's what you normally do. So we are given 4x squared plus 3x minus 5 is equal to 0. So before you use the quadratic formula, you always make sure that your equation is in standard quadratic format. And just to remind you, this is what standard quadratic format is. We've got ax squared plus bx plus c is equal to 0. So we notice that the equation is in that format, which means that we can go ahead and write down our quadratic formula and substitute in there. So substituting in here, our b value is 3. A is 4. C is negative 5. Now, it's always advised for you to simplify what you have before you get your solutions. So firstly, we've got negative times 3, so that gives you negative 3. Now, focusing on what's underneath the square root, we get 89. And in the denominator, 2 times 4 is 8. So working with the plus, we get x is equal to positive 0.80. And remember, the question specifically said that they want 2 decimal places. Or x is equal to, when you work with the negative, you get negative 1.55. Now here's the thing, grade 12s. This year, you are doing algebra the 3rd time around. And if you felt that algebra was hectic or confusing last year when you did exponents and surds and all of those laws of surds, which was quite new in grade 11, if you found that it was a bit difficult for you to understand, the good thing is that it's not tested at that level in grade 12. So because your algebra section is a revision of grade 11 and grade 10, it's tested in a way that actually affords you the opportunity to total the section. So what you guys should constantly be practicing throughout the second term is your algebra questions, whether it's solving for x, whether you're working on inequalities, but master those topics. If you found that you struggled with solving for x and y simultaneously, focus on that throughout the term. So focus on the parts of algebra which you struggled with, because this is the section where you can actually compensate for marks that you may lose in another section. So don't take it for granted that because you learned the work in grade 10 and grade 11 and you may have done well in algebra in those 2 years, that you'll be fine now. Remember, these are laws and rules that you have to revise and you have to do practice on in order to refresh your mind and in order for you to contain it. Okay, let's move on. So we're on 1.1.3. We've got x minus 1 all squared minus 9 is greater than or equal to 0. So what we have here is an inequality. Your aim with inequalities is to get x alone on the left-hand side. So the first thing we can do is take the minus 9 over to the right. We'll be left with a bracket on the left. Taking the negative 9 over to the right-hand side makes it positive. So that is going to become a positive 9. So now that we've got a bracket squared on the left, we can get rid of that square by square rooting both sides. So before I do that, I just want to move this 9 a little more to the right. Okay, so square rooting both sides. Please remember what happens when you square root a value is that it gets a plus or minus in front. Now on the left hand side, the square root and the square cancel each other out, so you're left with x minus 1. And that is not an equal to, it's a greater than or equal to. And when you've got the plus or minus of the square root 9, that tells you that this is either going to be the positive or negative 3. Now here's the thing. You are not solving for x. This is not an equation. It's an inequality. So at no given point in your working out are you allowed to write down an equal to sign. If you do, it will be marked wrong. But here's what we do instead. The values that x would normally be equal to, those are now known as our critical values. So you can do it on the side to show you're working out, which I'm actually going to do. It's not necessary though. From this step, you can go straight towards writing down your critical values, but I'm just going to show you how I end up with those values. To do this, I'm just going to say x minus 1. I am working with an equal to. Remember, this is just for your benefit, for you to understand how I'm going to get these values. So let's work with the positive 3 first. If you take this negative 1 over to the right, it's going to add on. We have 3 plus 1, which is 4. So now let's work with x minus 1 and negative 3 on the right. If you take the negative 1 over to the right, it is going to add on. We have minus 3 plus 1, which is negative 2. So this is what I want you guys to notice. Where x would have been equal to 4 and it would have been equal to negative 2, you are not allowed to say equal to. But what these now become are your critical values. So for our critical values, we have x as 4 or x as negative 2. So now all of this can be erased. Now another question may be, how do we write out this answer? Remember, your answer always depends on what your question has. Our question had a greater than or equal to sign, meaning that we're going to have 2 separate answers. We have x is less than or equal to the smaller value between your 2 critical values. So the smaller value is negative 2. Or x is greater than or equal to the bigger value, and the bigger value is 4. So that is how you would write out this answer. We're now on to 1.1.4. We have 5 to the power 2x minus 5 to the power x is equal to 0. Now, something that you should notice is that both terms contain 5 to the power x within them. But if it's not evident to you just by looking at it, maybe if I split it up, it would make better sense. 5 to the power 2x can be rewritten as 5 to the power x times 5 to the power x. Now, why are we allowed to do that? Think of laws of exponents. When you are multiplying bases that are the same, you add the exponents. So if we had to work backwards here, if we multiply the bases, or if we keep the base and we add the exponents, x plus x gives you 2x, right? So this shows you that 5 to the power 2x can be rewritten as 5 to the power x times 5 to the power x. Now let's keep our second term as is. By writing it out in this manner, what you notice is that it allows you to identify what is common in both terms. And we notice that, okay, in both terms, we've got 5 to the power x. So let's pull that out as a common factor. So taking out 5 to the power x from the first term, we are left with 5 to the power x. And from the second term, we're left with minus 1. Now let's equate each bracket to 0. So we've got 5 to the power x equals 0, or 5 to the power x minus 1 is equal to 0. Now, you guys have learned this in grade 9. When you are first introduced to these algebra concepts, you learned that if you have x as the exponent, you need to get the bases to be the same. Once the bases are the same, they cancel out with each other and you equate the exponents. So our aim here is, because we have 5 to the power x, we need to write each side as 5 to the power of something. But notice that we've got 0 on the right hand side. There is no power that we can raise 5 to that gives you 0. If you think about it, 5 to the power 0 is 1. 5 to the power 1 is 5. 5 squared is 25. And it continues. There is nothing, even if you look at negative exponents. Say you go with 5 to the power minus 1. That's 1 over 5. So there is no exponent that you can put on 5 that gives you 0. Which means that for the first part, 5 to the power x cannot equal to 0. There is no solution for that. Let's work with the second part. We've got 5 to the power x. Let's take the negative 1 over to the right. It becomes positive 1. And here you see 1 can be rewritten as 5 to the power 0. So we've got 5 to the power x is equal to 5 to the power 0. Now that the bases are the same, they cancel out with each other. And we can equate the exponents, so we have x is equal to 0. That is your solution. And if you take this value of x and you substitute into your question, if you have 5 to the power 2 times 0 minus 5 to the power 0, it should give you the right hand side. That's how you know it's correct. 1.1.5, we've got x over the square root of 20 minus x is equal to 1. Now you guys, this comes from grade 11. Remember the question where you had a surd and you needed to isolate the surd? So that is that type of question here. So as I've just mentioned, we need to isolate the surd. What does that mean? We need to get the surd alone on one side. Now here's the thing. We've got the surd with x in the denominator. What we can do is take this denominator and multiply across with the 1. So if we take this surd, which is a square root, we take the square root, multiply across with the 1. 1 times anything is always itself, so it's just going to be the square root of 20 minus x. Now the whole aim of isolating the surd is so that you can get rid of it. This is a square root. So to cancel out a square root, you are going to square. But because it is an equation, what you do on one side, you have to do on the other side as well. So squaring the left-hand side, we have x squared On the right hand side, the square and the square root cancel each other out. So we're left with 20 minus x. Let's take that 20 minus x over to the left. We have x squared plus x minus 20 is equal to 0. Now here you have a trinomial and it is a quadratic trinomial. So you can either factorize or you can use a quadratic formula. I'm just going to show you how to factorize since this is quite a basic trinomial. So we're going to fill in each bracket with x and x since we have x squared. Next, we are going to look for factors of the last term. Now, factors of 20 is 1 and 20, 2 and 10, 4 and 5. And here's the thing. We are looking for factors of negative 20. When we multiply them, they need to give us negative 20. But when we add them, we need to get positive 1. Now, the factors that we can use to achieve that would be the 4 and 5. However, for our sign manipulation, we need to use a negative 4 and a positive 5. So negative 4 times positive 5 gives you negative 20. Minus 4 plus 5 gives you positive 1. So this works out perfectly. So in one bracket, we will have x minus 4. In the other bracket, x plus 5. So now that we've got our factors, we would equate each bracket to 0 and solve for x. Doing so with the first bracket, we get x is equal to positive 4, or with your second bracket, you get x is equal to negative 5. So here is something that is extremely important, just in case you don't remember this from grade 11. Whenever it comes to these questions where you've got the square root in it and you need to isolate it, you always need to check your answers, because it's not all the time that both of them are solutions. So let's start off with the 4. You're going to go back to the question and you are going to substitute wherever you have x. So we're going to substitute. So we're going to have 4 over the square root of 20 minus 4. And when you press equal to on your calculator, that gives you 1. So that shows you that, hey, x is equal to 4 is a solution, since that works out. Now let's try x is equal to negative 5. So on your calculator, you will have negative 5 over the square root of 20 minus negative 5. But when you press equal to, you'll notice that you don't get positive 1. You actually get negative 1, which means that x is equal to negative 5 is not a solution of this question. So what we do is underneath that, we say not applicable. Now for 1.2, we need to solve for x and y simultaneously. So x plus y is equal to 9. And 2x squared minus y squared is equal to 7. So here's what we have to start off with. And when you look at your first equation, you realize that it's quite simple for you to make either x the subject or y the subject. So it's entirely up to you. If you make x the subject, you will have 9 minus y on the right. Or if you make y the subject, you will have 9 minus x on the right. I'm going to choose to make x the subject of the formula. So I'll take the y over to the right hand side, and I've got now x is equal to 9 minus y. So at the moment, since we know what x is equal to, we're going to take this and substitute in our second equation in place of x. So doing so, here's what I get. Notice that because it was an x squared, I substitute for x in a bracket and I've got the square outside the bracket. Now let's simplify this. So I'm going to keep the 2 outside the bracket. And since I've got a binomial squared, you know that it's going to result in a trinomial. Now since you're in grade 12, we avoid using things like FOIL method or writing out the bracket twice and then using FOIL method. Those are methods that you used in grade 10 and grade 11. Here we're going to use the shorthand method. So to get the trinomial, to get the first term, we square the first term. So 9 squared is 81. To get the second term, we multiply both terms together and we times by 2. That is going to be negative 18y. To get the third term, we square the second term. Negative y times negative y gives you positive y squared. Let's write out the rest of the equation. Now the next step is for you to take this 2 and multiply it into the bracket with all 3 terms. So we've got 2 times 81, which is 162. 2 times negative 18, which is negative 36y. 2 times positive y squared would be positive 2y squared. And the rest of the equation. Now let's get the like terms. This is what I'm going to do. Since I noticed that my y squared will be positive on the left, I'm going to get all of my terms over to the left. So going in order, I've got 2y squared minus y squared, which is y squared. Next to that, I've got negative 36y. And I'm going to take this 7 over to the left. When it goes over to the left, it will subtract. I've got 162 minus 7, which is positive 155. That is equal to 0. Now here I have a trinomial that is in standard quadratic format. The values are quite big, like the 155, so I wouldn't suggest factorizing. I would say go for using the quadratic formula. Let's do that. So here is our quadratic formula with the substitution. The b value was negative 36. The a value was positive 1. And the c value was 155. Now, once you simplify, the two solutions that you obtain is y is equal to 31 or y is equal to 5. So these are our values for y. Now that we know what y is, we can take these y values and substitute into the previous equation to solve for x. Remember, x was equal to 9 minus y. So here I have it. I've got 9 minus 31. My second equation, I've got 9 minus 5. So the first x value that I get is negative 22. And the second one is 4. So here we have solved simultaneously for x and y. Let's look at 1.3. It says given p is equal to 1 minus a and t is equal to 1 plus a squared, 1 plus a to the power 4, and it continues all the way up until 1 plus a to the power 512. Determine the value of p times t in terms of a. Now, that last question in your algebra section is always going to be something tricky. So they usually do end it off with a level 4 question. Something that requires an extra bit of thinking, but it's always something that you know how to do based on previous content that you've learned. So it's nothing that you won't be able to do. You just need to analyze what you have properly and see how you can best use your rules of algebra to work this out. Now, this is what we need. We need to get p times t. So we see that we are given what p is equal to. We're also given what t is equal to. So to get p times t, we need to multiply those brackets together. So let's start off by writing that down. Okay, so here is what we are given. And what we need to get is p times t. So we're going to take what p is equal to, which is 1 minus a, and we are going to multiply it by what t is equal to. So that's what we've done. Okay, here is p and here's t. Now, something I want you guys to notice is that if you look at your first two brackets, which is this part, I want you guys to ask yourselves a question. What format is that in? I'm going to give you a few seconds to think about this. What format is that in? Now, if you said difference of two squares, that would be correct. This is the factorized version of the difference of two squares. So we know that that bracket is the same thing as 1 minus a squared. Because think about it, if I give you 1 minus a squared and I ask you to factorize, will you not get 1 minus a times 1 plus a? Okay? Now I'm just going to write down the rest of it. So we've got 1 plus a squared, 1 plus a to the power 4, all the way up until 1 plus a to the power 512. And now when you look at what you have, notice these two brackets. 1 minus a squared, 1 plus a squared. Again, that is the factorization of the difference of two squares. Where in this case now, you would have had 1 minus a to the power 4. If you're going to factorize 1 minus a to the power 4, you would get 1 minus a squared, 1 plus a squared. Let's now write down what we're left with. We're left with 1 plus a to the power 4, all the way up until 1 plus a to the power 512. And again, you guys, these first two brackets, again, it is the factorization of difference of two squares. So those two brackets would be the factors of 1 minus a to the power 8. Because remember how it works is, you're going to ask yourself, what times itself would give you a to the power 8? Surely it has to be a to the power 4, because remember, when you are multiplying bases that are the same, you add the exponents. So if you have a to the power 4 times a to the power 4, when you add the exponents, it gives you 8. Okay, so that works out nicely. Now, within this dot, 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 you would have 1 plus a to the power 8. Okay, so I'm just going to write down what we're left with. But I want you guys to notice that working in the same manner, because remember, there's a series of brackets. There's a whole lot of brackets that's missing in between. So yes, your next bracket here would be 1 plus a to the power 8. And again, I would say that's difference of two squares. So that process will be repeated many times until this is what you end up with. Until you get 1 minus a to the power 512. And next to that, you would have 1 plus a to the power 512. And this would be the last time you have factors of difference of two squares, where these brackets would now be the factors of 1 minus a to the power 1024. And that is your final bracket. There's nothing left next to it. So this is what p times t is equal to. It's 1 minus a to the power 1024.